Good evening, everyone. Welcome to the third day of the 7-day online workshop on scientific editing with LaTeX. And today, our first session is going to be conducted by Bishwajit Deb on typesetting mathematics using LaTeX. And I was informed that some doubts from yesterday's class had remained. So whatever the questions that were remaining unanswered since yesterday's class, I request you all to kindly put the questions in the WhatsApp group or in the comment box. These will be addressed later after Bishwajit's class is over. So if everyone is ready, I would like to request Bishwajit to kindly proceed with the first class now. Thank you.
I can see only 25 participants are online. So shall we wait for 2-3 minutes? Let them to join others.
Yeah, we should, I think, wait for a few more minutes, then we can start. So in the meantime, I think we can address any remaining questions from yesterday if anybody wishes. Today's instructor Bishwajit is available, and yesterday's instructor Ramchaigri Brahma is also available to answer any doubts that have remained in yesterday's class. So please feel free to post the comments in the comment box.
Okay, I think we should start now. 35 participants are there. I can see, and I hope rest are also will also join within few minutes. So, good evening, all the participants. Myself, Bishwajit Deb. We have met already in the first class of this workshop, where I have presented you the basics, preliminary uh, things about the LaTeX, and followed by that lecture, you have gone through two more lectures. In the first lecture, in the second lecture, you have seen how accounts are being created in Overleaf and the first document, how it is being created. And in the third lecture, that is in you have learned a lot about the different ways of styling your documents in LaTeX. I hope you have gone through after the class, and if you have any doubt, you can. If you have any doubt, or if you are finding any difficulties while doing the same things that have been shown in the previous 2 days classes, you can feel free to ask in the WhatsApp group. and we will try to give you assistance whatever is needed. So in today's class we will learn about how to write mathematical formulas or mathematical equations in LaTeX. This is a very crucial lecture, and I hope you will give your 100% attention to this lecture, and I will go a little bit slow because a lot of commands will be used today's class and I hope you will try to catch up as much as possible because writing mathematics in LaTeX is all about using different commands. So to understand these commands, you have to understand how to use those commands and when those commands is needed to be used. And that is the most important part of writing mathematics in LaTeX. So let me share my screen. Anshuman, my screen is visible properly?
Yes, your screen is visible.
So in the two previous classes you have seen that when we start in LaTeX, that is we have to start with creating the document class, that is article. Document class, we have to write all the things under document class, and whatever we have to write, that is we need to create certain environments, that is document environment, that everything we have to write within begin document and document environment. So you can see Anshman, one more thing, the font is clearly visible, or shall I zoom it more?
It's visible properly on my computer screen, but I think you can increase it more for those of the students who are on mobile. It will be more beneficial.
I think this much zooming is perfectly visible.
Good enough.
Okay, so we have talked already that to use something, some basic things, some particular things, we need to use certain packages in LaTeX. Similarly, when we have to write some mathematics, we have to import some packages, that is the AMS math package. And AMS math package will allow you to use different type of commands that will be necessary mathematics in LaTeX. So in the previous class, it has been told that whatever that is written behind the begin document, that is before begin document, this part is called the preamble of your file, preamble section. In preamble section, all the packages have been included. So to write mathematics, I will first include the package which is needed to write mathematics, that is backslash. You can see just by using backslash, that user package has already been came. User package, you write AMS math. AMS stands for American Mathematical Society math. This particular package is named after American Mathematical Society, and within this mathematical package, almost all the mathematical equations can be written in LaTeX. Apart from this particular package, we need another more package, that is AMS symbol, SINB. This particular package is also needed when we use different type of Greek letters, different type of operators like del operator, D'Alembert operator. These operators, when you use in LaTeX, you need some other package, that is AMS SYNB, AMS SYM. So just keeping in mind, when we have to write mathematics in LaTeX, we have to use one or two basically packages. One is AMS math package and another is AMS sim package. AMS math package is for writing mathematical equations, and AMS sim packages for using different type of symbols, operators, etc. So these two packages are enough for basic equations also. You can write almost all equations with using this MS package, with these packages. Now coming to uh, how to start with writing mathematics. So there are two ways of writing mathematics in LaTeX. One is there are two ways or two modes are there. One is inline math mode and another is in display math mode. One is inline math mode. So what does it mean, inline math mode? Inline means, for example, there is some mathematics, there is some text, and you have to write a mathematical formula within the text, not separate from the text. Then we use this inline math mode. So inline math mode, we, for example, let us have a text. This is, and you will see this text will automatically come up. Now I have to put some mathematics within this text. So the first technique to do this kind of an inline math mode, that is using double dollar. This double dollar, you can use this double dollar, and within this double dollar environment you can write any equation, just like, for example, x plus y equal to 0, and full stop is there. This is my first equation. Now compile, you can see that the simple equation is visible within the text, x plus y equal to 0. This kind of environment is called inline math mode. Apart from this double dollar sign, we have other options also. That is, I am showing you the second option. Second option, backslash first bracket and backslash bracket close. Within this environment also you can write some other equations like x minus y equal to 0. Now compile it. See, x minus. So this kind of environment where we use the double dollar and backslash first bracket, is these particular environments are called delimiters. And within these delimiters you can write your equation, and you can write any in between any text. Apart from the second, there is another one technique which is used as backslash begin math, begin math and math. This is an environment, begin math and math, and in between begin math and end math you can write anything, any equation like c plus d equal to 0. Now compile it. You can see that the third equation has appeared in the output. So this technique of writing equation within delimiters is called inline math mode, where there are three possibilities. There are three techniques are there, where the first technique is using writing mathematics in between double dollar, where you can see this double dollar sign is there. Number two, using mathematics within backslash first bracket, backslash first bracket. This is the second technique you can use. And the third technique is writing begin math and end math within begin math and math environment. So this is the first way of writing mathematics in LaTeX, which we call math mode, inline math mode. And the facility of writing this, for example, if you have to write something mathematics within the text and you don't want to number it, you don't want to put some number against this particular equation, then we use this kind of inline math mode. And apart from this particular three styles of writing inline math mode, the most suitable or most used technique is writing within double dollar sign. So I think you have understood how to write mathematics by using inline math mode. So the next technique of writing mathematics is display math mode. In display math mode, this is the most used mode actually, because write a long equations or long calculations, you have to use this display math mode. Display math mode in there we use equation environment, and whenever we call this environment, that means it will start with begin, it will end with end backslash end. So I will start with begin equation. You can see it has already appeared. This is the environment, begin equation, end equation. So within this begin equation, end equation environment, we can write any type of equation. This kind of this style of writing equation is called display math mode. I am again repeating. In LaTeX, there are two modes of writing equation. One is inline math mode, and another one is display math mode. In display math mode, you can here use any equation just like simple equation x plus y equal to 0. And compile it. See, the equation has appeared. So these are the two modes. Apart from this environment mode, another type of command is also there in display math mode, that is I am showing you. That is backslash second bracket. This is backslash second bracket, backslash second bracket close. This is the environment you can use for display math mode also. And you can write the same equation x plus y equal x y equal to 0. Now compile it. We can see the equation appeared in the output. So in display math mode, there are two ways. One is begin equation, end equation, and another one is backslash second bracket. You can use any one of them, any one of the two sections. So these are the two writing styles of mathematical equations in LaTeX. Now, for example, you can see that when I have used this particular backslash second bracket, no equation number has appeared. No equation number is appeared. So keep it in mind whenever you want any kind of equation which should not be numbered in the text, you can use this particular command. But if you use that begin equation and equation command x plus 0 and compile it, you will see equation number 1 will be automatically there. You can see equation number 1 is automatically appeared in the document. Now if you don't want to have this equation number, the previous environment that I have shown, that is backslash second bracket, can be used. And apart from that, another environment that can be shown begin equation. You can see begin equation star, begin equation star, the same equation, right? You can see the difference. When I have used the environment equation environment, the equation number has appeared, but when I have used the environment equation star, equation number has disappeared. So remember, whenever you don't want to have the equation number in your text, use the star equation star environment, and if you want to have the equation number in your document, then use the equation environment. So these are the basics. Now we have let us start some more detailing about mathematical equation. Next come to the section I think in the hello. Hello.
Yes, sir, you are audible.
Okay. In the previous class, you have seen that we can use the section command to separate different sections. So I am writing different sections so that it will be much more clear for you. Now I will use the subscript. Superscript. How to write subscript and superscript in mathematical equation. Writing subscript and superscript. So remember, whenever we will write any equation, I have to start with begin equation. I have to start with begin equation or whatever may be the environment. So subscript means that indices that come below, and superscript that comes in the upper position. For example, let us start with superscript. Superscript, I think everyone we have gone through the formula a plus b whole thing square equal to a square plus 2ab plus b square, where the square appears as a superscript. So how to write this superscript? Just start with a plus b. I have done. Bracket is closed, first bracket. Now I will use this cap symbol. This symbol is called cap, or sometimes it is also called circumflex symbol. Cap or circumflex. Use this circumflex for superscript. Now in superscript position, square is appeared. That means 2. It's done. A plus b whole thing square. Now I have to write a square. Same procedure, I will use this cap, a cap 2 plus twice ab, 2ab plus, now I have to write b square, that means b cap 2. Now compile this equation, I think it will see the equation has appeared. A plus b whole thing square, a square plus y cube plus b square. So when you have to use the superscript, use this cap 2. This cap, this is the basic command for writing superscript. For example, if you have to let us take a situation where you have to write two indices apart from 1 and 2 indices. How can we write two indices in superscript position? Again, I have to start with begin equation. I have to start with begin equation. For example, x to the power a cap. I have two indices, for example xy. When you have to write two indices, you can use, or two indices or combination of two indices, you can use the curly bracket. That means x plus y. Here. Now run. Now see, x to the power x plus y. So when some combination of indices will be required to put, use this curly bracket. Use this curly bracket after cap symbol. So this is the way of writing superscript. Now similarly, we can write subscript also. For subscript, the same equation, for example, I want to write ax. For subscript, you have to use underscore ax plus b underscore x equal to c underscore x. Run it. The equation has appeared. Ax, where x is in the subscript position, plus bx equal to cx. Similarly, if you have to use some combination of indices in the subscript position, For example, a to the power a, then you have to use the curly brackets you have to use, and within the bracket you can write x plus y, whatever maybe the combination x plus y or x minus yz. Here. Now run this. See, at x minus yz, this kind of notation has been appeared in subscript. So remember, when we have to use superscript, use this cap symbol, and when you have to use subscript, use this underscore sign. And for combination, you can use curly bracket after cap or underscore. This is the command for writing subscript or superscript in LaTeX. In the next section, there are lot of Greek numbers, Greek letters has been used in mathematics, like alpha, beta, gamma, pi, kappa, omega. A lot of symbols are there which are always used in mathematics. So how to write these symbols? In Microsoft Word, you can directly import those symbols from there is an option called insert option, but in LaTeX you cannot directly import those symbols. For those Greek letters, there is specific command for each Greek letters in Greek letters is used in LaTeX. For example, I have to write alpha. What is the I have to write alpha. The command is \AL /alpha, alpha. Now run it, you can see alpha has appeared. For example, you have to write beta \beta, BETA. That will appear. For example, if you have to write gamma \GAMMA, gamma. Now run. This alpha, beta, gamma sign has appeared. So for these symbols, you have to write this particular commands. Those commands are inbuilt in LaTeX. And for example, this pi, that is \PI, pi. And for all the Greek letters, there are specific commands are used in LaTeX. So apart from this, some other mathematical relations are also there, or basic operations, that is plus, minus, division, multiplication. How to write plus minus? For plus minus, you can simply use LaTeX. But for the multiplication and division, there is a specific command. How to write those? How to write plus minus is simply you can use the plus minus that is available in your keyboard, but for multiplication you have to use \times, TIMES, times for multiplication, and for division you have to use \div. These are the two commands used for multiplication and division. Now run this. Let us see. Yes, you can see plus, minus, multiplication, division. These are the signs, basic mathematical operators that is used in mathematics. Now, apart from these operators, there are some other operators, that is Nabla operator. Nabla operator, those who are from physics or those who have gone through calculus, they know what is this Nabla operator. Nabla operator is written as backslash NABLA, Nabla. I think you have seen this Nabla operator. This Nabla operator, this is extensively used in calculus and tensor. Nabla operator. Apart from this, there is some partial derivative operator. How to use this partial derivative operator? Backslash PARTIAL, partial del operator. That is also used in case of classical or algebra also. It is in tensor also. This partial del is also. And apart from this, one more operator that is extensively used in mathematics, that is D'Alembert operator. How we write it? Using backslash square, SQUARE, this box operator. I think you can see this box operator is appeared. This box operator is called D'Alembert operator. So these are the 5 basic operators that are used in mathematics. 5-6 operators, the 4 basic operators, plus, minus, into, division, and Nabla, del, and box operators. How to use these are the specific commands that is used to write these operators. I request all the participants to note down these particular commands in their copies, because these commands are required whenever they will start writing mathematics. Now, apart from this, in mathematics, some relation symbols also. Apart from this, we have some relation symbols also. What are those relation symbols? For example, I am writing one by one. That belongs to sign. What is this belongs to sign? I think once I have seen. This belongs to sign is extensively used in real mathematics or real algebra. It is used as backslash in. For example, not belongs to uses not not in. It is used for not belongs to. And perpendicular sign. How to write this perpendicular sign? Backslash PERP. Perpendicular sign. Then we have subset that is used in real mathematics, real algebra. This is the command is used for subset is backslash SUBSET, subset. See, the subset symbol has appeared. Now, for example, approximate. This also use APPROX, approximate symbol. And another important that is used symbol, symbol that is used in geometry. It is the command for congruent is CO backslash CO and G. See, the congruence has appeared. So this kind of different type of relation symbols are also used in LaTeX, and for all those relation symbols a particular command is used in LaTeX, and I hope you have gone through all these particular commands for particular symbols. So till now we have gone through 5 things. The first, we have the different mathematical modes in which mathematical equations are written in LaTeX. Number 1 is how to use subscript and superscript. Number 2, how we can write Greek letters. Number 3, how to write basic operation. Number 4, how to write relation symbols in LaTeX. Now coming to 2 important things, that is fraction and square root. How to write square root things. how to write fractions in square root. Now let us start with square root. The command for writing square root is \sqrt, and you see the command is there and the curly bracket is here. Whatever you have to write in between the square root, that you have to write in between these curly brackets. For example, I want to write 1 plus square root or root over 1 plus x, 1 plus x. Now compile it. You can see root over 1 plus x has appeared. So the command for writing square root is \sqrt, and whatever you have to write within the square root, that is, you have to put that whole thing within as 1 plus that curly bracket. For example, if we want to write x square plus y square, use x cap 2 plus y cap 2. That cap is used for square writing square. Now compile it. Now you can see square root over x square plus y square has appeared. So this is the basic command for writing square root. Now how to write fraction? So for fraction also there is a specific command used in Latin. The command is frac, frac, \frac. Now you can see that there are two curly brackets. The first one is for numerator, second one is for denominator. So whatever you want to write in the numerator, you have to write in the first curly bracket. For example, I want to write x by y. So x in the numerator, so I will write x in the first curly bracket, and y in the denominator, so I will write y in the second curly bracket. Now run this, we will have x by y. See, x by y is there. For example, any different kind of mathematical equations involving fractions, you can use this \frac command. For example, I want x, some complex x by x square plus y square. Let me copy from here. Now see, x by x square plus y square. So anything you want to write in the numerator, write in the first curly bracket, or anything you want to write in the denominator, write in the second curly bracket. So these are the two commands for writing fractions and square roots. So we have learned about how to write fractions and square roots also. Subscript, superscript also we have learned. Now we will learn how to write tensors. Tensors, those who are from physics, specifically from physics, they have gone through tensors from the degrees, 5th or 6th semester. Tensors are there. Those are for mathematics also. They all tensors. So how to write tensors? Tensors are basically also notation. So scalar, specific scalar vectors, but we specifically learn how to write those tensors, different types of tensors. Superscript. The formula is same. The whatever we have used in case of writing subscript, superscript. For superscript, we have used that cap symbol, or subscript, we have used that underscore. The same command will be used writing tensors. For example, I want to write a tensor mu, that is in subscript underscore mu. How it will be? Mu is \mu. I have already told you that for Greek letters, particular command is used, that is for mu, \mu is used. Now let me compile it. You can see a with subscript mu. Tensor of rank 1 is appeared. Similarly, you can use different tensors of rank 2 also. How I can write tensor of rank 2? \mu. For example, I want to write mu 2 with 2 rank indices. 1 minute. For There is a mistake because whenever you use two indices or two combination of two indices, you have to always use the curl bracket. Tensor of rank 2 mu nu has appeared. Now similarly, I want to write tensors of superscript rank, which tensor where the indices will be in superscript position. How to write? Cap symbol will be used. Okay. B tensor with superscript has appeared, B mu. Similarly, if you want to write tensor with 2 or 3 indices, you have to use the curl bracket after cap. For example, new backslash new backslash gamma. I am using 3 indices here. 3 superscript indices. You can see B mu nu gamma has become. Now, if I want to write tensors of mixed rank, mixed tensors, that means where both subscript and superscript also there. For example, mu nu, where mu will be at subscript, mu will be at superscript. What is the? So first write the subscript. For subscript, use underscore backslash mu, and for superscript then and backslash mu. The technique of writing mixed tensors, you can see mu is the subscript, mu is the superscript. The technique is first you use underscore the subscript notation, then use the cap for superscript notation. This is the technique for writing mixed tensors. For more rank or more indices, you use the curl brackets. For example, a underscore curl bracket backslash mu backslash mu, 2 indices in the subscript position and superscript position, curl bracket backslash alpha backslash beta. Compile and see how it appears. See, you can make tensor of rank 4 where mu nu at the subscript position and alpha beta at the superscript position. So the same notation, the same command that is used in writing subscript superscript also used in writing tensors in LaTeX. Now we have learned how to write tensors. So for example, let us try one more equation, that is the famous equation, is the Einstein's equation. Let us see. That is we know that Einstein equation, those who are from mathematics and physics, they will very much familiar with Einstein equation. Let's write Einstein equation. So we will start with backslash begin. So you can see that every time I am writing anything in LaTeX, whatever may be the symbol or whatever may be the even if it is a simple equation, I am using the begin equation and equation environment. So Einstein equation is R mu nu R. So R mu nu, I am using the subscripts R mu. So R mu nu minus half of, I have to use half, means 1 by 2. So I have to use the fraction, FRAC fraction, half, 1 will be at, and second will be 2 will be in the half, G mu R, G mu nu, G underscore backslash nu equal to P mu nu, P underscore backslash nu. So I think our equation is complete. Let us compile. Famous Einstein equation. Yes, you can see the famous Einstein equation, R mu nu half of R G mu nu equal to T mu nu. So like this way we can write tensorial equations in LaTeX. So this is the one example I have written. So you can see how these tensor equations are being written in LaTeX. Now coming to, we have to almost 45 minutes have passed, so we have to move a little bit faster because a lot of things are there still left we have to cover. So now I have two equation. I have to align equation. I have two equations that I want to align. How to align equations? So this is also done within a particular. For example, I have two equations. One is in the upper position. One is and next one is in the below position. How to fix the position of the two equations, or in other words we can say the justification that is we done in writing text. So that's the exact way we do while justifying the text, the same we will do in case of alignment of the equations. So how we do it, we start with an environment that is called begin align, ALIGN. If remember this particular environment for writing two equations in alignment. So let us write first equation, x plus y equal to 0, and you know that when I have to go through the second line, we do a page break or we do a line break with the double backslash. In the this is used for line break. That means I am going to the second. In the second equation, for example, c plus d equal to 0. Now I want to place those two equations with perfect alignment. To use this alignment, we use ampersand. This symbol, this particular command ampersand before this equality. That means these two equal signs will be in alignment. Now compiling, see both the two equations are in alignment where these two equality symbols are in alignment. For example, what does it mean if I use the mode these two parts will always be aligned no matter how long the two equations are. So this is how we will do alignment. Now thing is that in many times we use two equations but we don't want to number one particular, or we use set of equations which will be numbered for one numbered as a one equation. That means here the for first equation, equation number 13, equation number 14 has appeared, and I want only one equation number. So if you want one equation number, just before this double backslash use backslash no number, no number command, no number command. You will automatically see from the first equation number will disappear. See, from the first equation number has disappeared. Now I want equation number in the first equation and equation number don't want equation number in the second line. I will use no same backslash no number after double backslash. See, equation number has gone up to in case of the first equation. So this is a technique where if you want to remove the equation number by using backslash no number command. Now for example, I have three equations and I want one equation number, and this kind of 3 or 4 or 5 more than even 6 7 equations, I want only one equation number. How it is done, I am telling you. This is as a particular environment is also used. First I will use begin equation environment, and within begin equation environment we will use again another environment in aligned, ALIGNET, begin aligned equation. We will use another environment within equation environment that is begin aligned, and we will use the same We don't need no number. For example, two equations is there, and I want another q plus s equal to 2. But you have to use the justify symbol, that means ampersand before. Now let us see how it appears. See, three equations are there with one single number in the middle. So these are different styling aspects. You can use the previous one also, and this aligned environment also for or aligning equations. And if you want to have one more equation line, then use the backslash and come to the next line and some z minus py. But use this justified symbol and percent. Let's see how it appears. See, four equations with one number. So in this way, you can use multiple equations with one equation number. And if you don't want any equation, all equation with all equation number, use the simple this one with no number. Don't use no number command. But if you want a particular equation to be numbered, then use this kind of either this no number command or this kind of begin aligned environment. Apart from this, another technique is also there. I will try to show you how to writing those equation with justification alignment, that is begin equation. Within begin equation we will use another environment, begin split environment as SPLIT split environment. We can use this split environment, and let me write the same equation. Control C, same equation within split environment. Control E. I am writing the same equations with same ampersand justified sign, and see whether it is appears as the previous one. You can see both the two equations are identical. They have appeared exactly same. You can use, that means if you want this kind of equation with single equation number, you can use either of the two techniques, that is writing aligned environment or using split environment. So both the environment writing this kind of equations with particular alignment and particular equation number. So we have done a lot of about alignment of equation. Now we will do breaking of equation. For example, in many times when we write equations that are too long, and a very long equation, and you cannot put the same equation in just one line and it continues after 2-line, 3-line equation. In those cases, you have to break long equations. How we can use how to break long equations? For example, I am simply writing an equation x plus y plus z plus. For example, a long equation equal to 0. A simple equation is there. It is a very long. You can see it is a very long equation. And I want to break this equation. For example, I can elongate it even more. You can see a very long equation. Now I want to break this equation because I don't want this such a long equation, and I want this equation to be appeared in 2 lines. How we can break? For breaking equation, we use a specific environment, that is begin multi-line. Within multi-line environment. To use multi-line environment, for example, I will use the same equation I have written in the previous section, controls and copy pasting. Same equation, and I want, for example, I want to break this after where this minus sign has started. Here I want to break this equation. Simply you can use double slash here. From here, after this minus sign, want to break this equation, use double backslash after this minus, after this part. Now we can see what happens. We will see. See, this equation has been broken. This equation, this type of multi-line environment can be used to break long equation. Apart from this, but you can see this breaking equation is not justified. That means that long part is from here, that short part is from in the line, and I want to break the equation with proper justification, with proper alignment. Then we will different and another environment that is the same aligned environment we have used. We have used this particular environment previous also in the just before section 5 was aligning equation within equation environment. We will use environment, and let me write the same equation, control C, control V. I am using the same equation here. For example, I want to break this equation from here, and I will break this equation from here with the same double backslash sign, and I want this part to be appear somewhere here. Any place where you want to justify this part, just put, for example, I want to justify this part with this part, or align this part from this part, use here the and part sign. See, after this third term, I want to have this equation. If I want to have this equation after this rest part to be aligned with, after we will use this and signature and symbol after fifth term. 1, 2, 3, 4, 5. After this term, I will use this and term, and see how it will align. See, after fifth term, it is shifted towards right direction. So using this aligned environment within equation environment, we can break this equation and alignment. We can do both the things. You can break as well as align the equation from the upper equation and upper line with the below line. So remember, this particular command is used for this aligned environment. Aligned environment is used for breaking equation as well as aligning two equations, three equations. So we have learned about how align equation and how to break long equations. Now coming to some important brackets. How to use simple first bracket. How can you use the first bracket? X plus y, simple first bracket. For second bracket, use the second bracket, x plus y. For third bracket, curl bracket, remember this curl bracket you cannot use, because this curl bracket has a particular meaning in LaTeX that is used in this kind of command. So you cannot write this curl bracket, it will not appear in the output. You have to write backslash curl and write x plus y backslash curl. So for curl bracket, you have to write curl backslash curl. You can see x plus y within first bracket, x plus y within second bracket, x plus y within curl bracket has appeared. In some cases, in quantum mechanics or mathematics, we use bracket notation. In bracket notation, you know how to use how. For example, I want to write bra or cat notation. How to write bracket? For bracket, you use a particular code that is Langle, L-A-N-G-L-E. Langle, for example, x and this bar. See how it appear? See, this bra has this particular notation for bra, x has appeared. Now I want the cat notation. How I will write cat notation? This bar y backslash wrangle, R-A-N-G-L-E. Remember this, for bra we use Langle, L-A-N-G-L-E, and for cat we use wrangle, R-A-N-G-L-E. See, bracket notation has appeared in the output. These are the codes how to write long brackets in mathematics, LaTeX. Now, for example, we use equation, a very big equation. How we can write big equations, big brackets. For big brackets, we use backslash L-E-F-T backslash R-I-G-H-T. This is the code. Within the backslash left first bracket and backslash right first bracket, you write anything. For example, I want to write section x I y. See how it will appear. Okay, long bracket. One minute. Okay. See, this equation has appeared with this x by y with long bracket has appeared. So whenever you want to have a long bracket, use this particular backslash left and backslash right environment or command. Now we have seen how to write brackets. Now there is important operators are there, which are there are some operators. Sine cos tan. How to write sine cos tan? For sine, use backslash sin. Backslash sin. There's a backslash sin for cos, backslash cos cos, for tan backslash tan, for sec backslash sec. This kind of, for cos backslash cos, for tan backslash tan, for sec backslash sec, for cosec backslash cosec, for backslash cot. These are the commands for writing sine, cos, tan, sec, cot. Why there is a red mark has appeared? Because sine cannot appear single wise. Sine is always sine of x or sine of y, anything like this. So now you see there will not be any error. See, sine of x. So let me write one particular equation, sine of x plus y. All of us are aware of this particular equation, sine of x plus y, that is backslash sine of x backslash cos of y plus backslash cos of x backslash sine of y. See how it appears? we can see that sine of x plus y is sine of x cos y plus cos x sine y. This kind of trigonometrical operators are being written in case of LaTeX with this particular command backslash sin, backslash cos, backslash tan. So remember those texts with backslash symbol. For hyperbolic function, we write hyperbolic function. For example, I want to write sine hyperbolic backslash sine h. You can see it has appeared already. Backslash sine h for sine hyperbolic, backslash cos h for cos hyperbolic. So you can use these trigonometrical operators using this particular course in LaTeX. Now we have seen also we are at the end of our lectures and very 2-3 things has remained. Almost we have covered a lot of things. The 3 important things are left, which is limit, integration and summation. Limit, integration and summation. Let me start a new section. Limit, integration and summation. How to write limit, integration and summation in this section we will learn. So first of all, we have to start with begin environment. So for writing limit, we will use backslash lin. Lim. Backslash lim is the code. For example, backslash lim is written and limit of x or limit a anything. So whether it is appearing or not, backslash lim. See, it has appeared backslash. Now I am to write. I want to write some more complex with limit, particular limit. I want to write the put the limit within the below the limit. Since we will write below the limit, so we will use this underscore and we will use the curl bracket. Always remember when we use combination of subsets, we will always the curl bracket. So from x tends to 0, for example, I want to write x tends to 0. How will we write? X tends to will be have a particular backslash 2. That backslash 2 stands for x tends to 0. X tends to 0 and some x is some x square, for example, x square. See how it appears? See, you can see in the output limit of x square where x tends to 0 has appeared. So with using this kind of technique, we can write limit. So one more famous equation I will show you. Control C for saving time. I am copy pasting. Limit x tends to 0. Writing famous equation. Sine of x divided by x when limit tends to x tends to 0 is equals to 1. I am writing this particular equation. So since sine of x by x, so I will use the exact environment in the above. In the first section, backslash sine of x, and the second section in the denominator there will be x and it will be equal to 1. Let us see. See the famous equation in trigonometry, the famous identity where sine x by x when limit tends to x tends to 0 equals to 1. So this kind of limit we can write using this simple technique or simple command. Now we have understood how to write limit. Now another part is integration. How to write integration? So same for integration, a particular command is used. We can int. In int integration. For example, I want to integration of x square, x cap 2, and for dx there is a particular code backslash comma. Remember, for dx writing we have to use backslash comma d of x. see, integration dx has appeared. For integration signal, this cookie symbol use \int. This x square part, this is a simple part, anything can be this integral part. And for dx you have to use this \dx for writing this dx. Remember this. Now if you want to use put limit, that means you have to put lower limit, upper limit. For lower limit use underscore curly bracket. For example, I want to integrate from 0 to 1. I will use in the lower limit for 0, and for upper limit I will use cap, and within second bracket use 1. See, limit has appeared. Lower limit has appeared as 0, and upper limit 1 has appeared. So writing limit, the code is, you can see in your screen, that is for integration \integration, and for lower limit write underscore within curly bracket whatever will be the limit, and for upper limit after lower limit writing use this cap symbol, and within curly bracket whatever will be the upper limit you can put it, and using this you can write integrations. This is a line integral, that means only one-dimensional integral. If you, for example, if you want to write two-dimensional integral, I will use \int. Two-dimensional integral, I will use int, and since two-dimensional or means there will be two variables, and integration will be done for two variables. For example, I am using some variable x u function of x comma y, some function of x comma y, and so it will be, there will be two dx and dy. So comma dx, again comma dy. Let us see how it appears. See, this area integral, double integral, this is for u of xy dx dy. For dx dy we have used comma dy. Similarly, if we want to do volume integral, I will use the command \ii int, and the same code will be there. For example, Control C, Control V. I will use three variables x, y, z, and the line element also will be there, t comma dz. Let me compile. See, three variables has appeared. Three integration which we call volume integration has appeared. For line integral only int, for area integral double int, for triple integral or volume integral \iint, and the same for line element dx, dy, dz. You can use this as many as line element, as many as dx, dy you have to write. And one left integral, that is closed integral. How can we write closed integral? In some cases we have to write closed integral. The code is OINT, \OINT. That's the same. The command is \OINT. You can see the closed integral symbol has appeared. So very simple. For line element \int, area integral double int, volume integral triple int, and for closed integral \OINT. Same. And last one thing that is left, how to write summation signals. How to write summation. Now, to write summation, we have to use a particular command \sum. \sum. For example, \sum x to the power n. Let us see how it appears first. Summation symbol will appear. See, summation symbol has appeared. X to the power n. Now I want to put the limit. The same technique will be used for lower limit. For example, n starts from 1 to capital N or 1 to 10. So underscore n equal to 1, and for upper limit cap curly bracket of 10. See, summation of x to the power n, where n tends to x to 10, n tends from 1 to 10. This kind of equation summation, backslash sum can be used. Similarly, we can write product of using backslash prod, P-R-O-D, backslash prod. Let me use the same control C. Let me see first how the product of sign has appeared. See, the product of sign has appeared to the power x to the power n, and I again want to put the limit. Same limit I want to put in case of product of. So after product of, use underscore, I am using the same technique to put limit. See, the limit has appeared where n starts from 1 to 10. So same technique can be used to write sum over or product over notations. So we have done almost a lot of things and covered almost all the basic techniques, and I hope you have noted down all the things, and I will share this particular all those codes that I have written in the note. I will share in the group. So I will stop here, and I will ask anyone to voluntarily share the screen. I will request anyone to share the screen so that we can do a very quick hands-on session. Don't be afraid. We are just learning. I understand everyone of us just learning basics. So I request any one of you, please share your screen so that we can do the very simple equations. And you might be afraid of, because we have gone through a lot of commands today, but keep in one thing in mind. Once you start writing in LaTeX, you will get to know those things, and once you know all the commands, I am telling you, it's very fun. Almost you can play in LaTeX with the commands. So I request anyone from the participants, please share your screen. Please don't be afraid. We will help you.
David, or perhaps any one of your batchmates or department students.
Okay, all right. Today, just a minute. Today only I told this astrophysics people to start drafting their projects. At least they are sure of the name of the project, so they can start writing and start using those commands, whatever they're learning, just arbitrarily.
I'm again telling all the participants that in our module you have kept a hands-on session so that you once you try to do by yourself you will learn easily. And one thing, if just by listening to these lectures you won't learn anything, I am telling you, until and unless you start doing LaTeX by yourself, no matter how many errors may appear for the first time, you won't learn anything. And even if we give you lectures for 15 days, 20 days, nothing will be help. You won't learn start doing it by yourself. So I again requesting, please share anyone your screen.
Yeah, of course.
All the participants, please, whatever we are giving you the commands, please practice at home. And once, yes, I can see someone has shared a screen. So,
Hello, sir.
hello, Khairul. So you have done many equations, I can see, the integration, summation. Can you write this simple equation, a plus b whole thing squared? Just start with a equation environment. Begin equation. Yes. Now I want to write a minus b whole thing squared equation. A minus b whole thing squared. Please try how to write first bracket. No, sorry. Start with the first bracket. No, you have used curl. Don't use this curl bracket. You can use shift 9. Use shift 9, or you can use the simple, yes, y 2 x square. So you have to start with x cap 2. Don't go, no. Don't go to the second line. It will appear as an error. Remove this one. Write x cap 2 plus twice xy you have used to equality symbol, equal symbol. Shift equal, yes. Twice xy, y square plus twice xy. Yes, now you can run the program. See, x plus y whole thing square equal to x square plus y square plus twice x square has appeared. So in this way you can write simple equations. So we will try one more equation. So start with begin equation and equation environment. So we will write some famous tensorial equation. Khairul, are you from physics background?
I am from Assam University Physics Department.
Okay, so I think you know that Einstein equation, G mu nu equal to T mu nu. So we will try to write this G mu nu equal to T mu nu, where mu nu will be appeared in the subscript position. So how to write subscript position? G, then no. For subscript position you have to use underscore. Yes. Since there will be two indices, what we have to use for two indices? We have to use curly brackets. Put curly bracket, yes. Under now we have to use two Greek letters, mu or nu, mu and nu. So what are the commands for mu? Backslash mu, and then yes. Now equal to T mu nu. Write in the same way. T stands for stress energy tensor. Now compile. See, G mu nu and T mu nu. Can you zoom it out? This PDF section. In the PDF section, can you zoom so that other participants can see? No. You put your cursor just below the compiled section. Put your cursor just below the yes. You can see yes, zoom. That is zoom. Now justify. Yes. Yes. He has done a previously he didn't put this underscore sign, so now he has put this underscore sign. You can see both these new indices has appeared in the subscript position. So one algebraic equation he has written, one tensorial equation he has written, and one last equation we will again try. So Hyrule, can you please start again the equation environment? Backslash. We will write one trigonometric equation. For example, cos x plus y. Cos x plus y, so definitely there will be bracket before x. So the formula is cos x plus y. I don't think whether you remember cos x cos y minus sin x sin y. Right? Cos x cos y sin x sin y. Minus. Oh, you have used. Now to compile. See how beautiful it has appeared. Cos x of x plus y equal to cos x cos y minus sin of sin y. So I thank Harul for coming out and help me to do this small hands-on session. So I am again requesting all the participants to go through whatever I have given or in the previous class the tutor has given you to do it by yourself. And if you feel if you feel any difficulty, please come out and put your questions in the WhatsApp group. So I hope within this 7 days you will get to learn basics of writing LaTeX, and after you can do by yourself. So thanks a lot. We have completed this particular session in time, and I hope you have noted down all the commands that I have shown you today for different activities, and I will show these commands in some written mode so that you can again check it out if in case you have missed it in some parts. So thank you everyone for your patience and meet you tomorrow. Thank you. Anshuman?
Thank you, Bishwajit, for the wonderful session today. So, Shabina, have we provided the attendance link yet?
Yes, link has already been provided. I can see.
Okay, fine. So, those of you who have attended today's session, please make sure that you fill your attendance sheets at the earliest. And if there are any doubts remaining from today's session, as Bishwajit has just mentioned, please feel free to post the doubts in our WhatsApp group, or even you can mail any one of the speakers. There are no issues. And if there is nothing else from any of the participants, I think we can end our session today with Madam's permission, ma'am. So I think we can conclude for today, Bishwajit.
Okay.
Yeah, okay. Thank you again, guys. So tomorrow we will see you again at the same time. Have a good night. Thank you.